Okay, number 87. We have a quadratic x plus 3 quantity squared minus 1. The parabola opens up because a is 1, which is bigger than 0. Is that true or false? That's true. The vertex is 3 comma negative 1. No, it's negative 3 comma negative 1 because the h value is the opposite. Okay, 88. We have a parabola, and we need to find the vertex. In the book, Cynthia does it kind of a weird way, which we're not going to worry about. So if I have 2x squared minus 6x minus 18, I'm going to slide this over and pull a 2 out of there. So 2 times x squared minus 3x, leave a space, minus 18. So what goes in the factor? X minus 3 over 2, and we square that, so we need to add 9 over 4, but it's not really 9 over 4. It's 2 times bigger than 9 over 4, which is 18 over 4. So I'm going to subtract 18 over 4 out here. So negative 18 minus 18 over 4. And I get negative 45 over 2. Oh, well, we didn't need to go that far. The x-coordinate of the vertex is negative 3 halves. Nope, the x-coordinate of the vertex is going to be the opposite of negative 3 halves. That's the mistake. It should be negative. It should be positive 3 halves. Yeah, I didn't really need to go that far, did I? So x minus 3 halves gives us an h value of 3 halves. The book said that the h value is negative 3 halves. And the formula is x minus h squared. So whatever's inside there, the x coordinate of the vertex is the opposite. No, you could have looked at it. Oh, yeah. That's true. And we don't want to do that the way that Cynthia does because you'd have to memorize a formula, and we don't want to memorize formulas if we don't have to. Okay, 89. Rewrite the following quadratic in standard form. So, group the variables together. So they slid the 3 over, pulled out a negative, but they messed up. Right, the 2x. A negative needs to come out of 2x. Yeah, so the mistake is in step 2. Find the quadratics whose vertex is 2, negative 3, and whose graph passes through the function 9, 0. So we need to plug in h, k, x, and y. They plugged in... Oh, so the h and the k got put in correctly, but the x and the y were switched. They plugged x in for y and y in for x. Okay. 91. A quadratic must have a y-intercept. Is there any way you can draw a parabola that misses the y-axis? No. Okay, 92. A quadratic function must have an x-intercept. False. What happens if if you don't have x-intercepts? You get imaginary roots, and we'll talk about those, but not right now. 93. A quadratic function may have more than one y-intercept. False. That means it would not be a function, and all quadratics are functions, so that can't happen. 94. A quadratic function may have more than one x-intercept. True. And then 95, for the general equation, quadratic equation, ax squared plus bx plus c, show that the vertex is h comma k. Oh, yeah, we don't want to do that. Throw that one out. Let's cross it out. So let me show you what they're asking on 95. So ax squared plus bx plus c. Let's complete the square. So what do I need to do here? And you move that over, and I pull out an a. What do I get when I pull out an a? X squared plus, so if it were an 18 in the middle, and I pull out a 3, how would I get that middle number? 18 divided by 3. So if it was 18 and I pulled out a 1/3, what would I do? 18 divided by 1/3, which ends up being times. So how do I pull an a out of a b? B over a. So b over a x, leave a space, plus c. Okay. Now it's going to be a times what? X plus b over, it's half of b over a. How do you cut a fraction in half? There are two ways to do it. Cut the top in half or double the bottom. So in this case, we're going to double the bottom. B over 2a squared. And it just wants, okay, it wants both of them. So what goes here? B squared over 4a squared. So b squared over 4a squared. Now, it's not really b squared over 4a squared. It's b squared over, or it's 4, nope, correction. It's a b squared over 4a squared. So a b squared over 4a squared is really just b squared over 4a. Right? So I'm going to add that to this, or subtract it. So negative b squared over 4a plus c. So negative b over 4a plus c. Now, this needs a common denominator. Oh, squared. The common denominator is 4a, so I'm going to put a 4a here, and then a 4a on the bottom. So my x-coordinate is the opposite of b over 2a, and the y-coordinate is negative b squared plus 4ac over 4a. Oh, and she cheated. F of negative b over 2a. So Cynthia said the opposite of this is the x-coordinate. So she's saying that negative b over 2a, or 4a, that is the x-coordinate. What's the y-coordinate? Whatever you get when you plug that in. So she said this, which is kind of a cop-out, right? We know what it is. It's actually negative b plus 4ac over 4a. Now, that looks an awful, b squared, thank you. That looks an awful lot like the quadratic formula. And the quadratic formula is created by completing the square on ax squared plus bx plus c. So that's where it comes from. Yeah, I'm going to throw that one out. I don't like that problem. Given the quadratic function a times x minus h squared plus k, determine the x and y intercepts of a, h, and k. So this is actually pretty easy. Y equals a times x minus h squared plus k. I just need to get x by itself. Yeah. How do I get x by itself? Subtract the k, y minus k. Divide by a. Take the square root with the plus or minus. And then add h. If y equals 0. So that is the equation as long as y equals 0. So the equation is negative k over a, the square root, plus or minus, plus h. So that one's actually pretty easy. And then 97. Oh, you're paying attention now. Okay. So 97. A rancher has 1,000 feet of fence to enclose a pasture. Determine the maximum area if a rectangular fence is used. So in a rectangular fence, we have one side that would be X. What would the other side be? 1,000. So this would be X and X. If I build this and this, how much fence have I used? 2X, right? How much fence do I have left? 1,000 minus 2X. So I have 1,000 minus 2X left. And how much of that is going to go right here? Half of that. So this length is 1,000. No, because you're not sure it's... Oh, I see what you're saying. So once we get here, can we simplify? Yes, you can. So 500 minus X. Okay, so what is the area of that rectangle? It's just L times W, right? So X times 500 minus X. So I essentially get negative X squared plus 500X. Now what do I want to do? I want to graph it and find the vertex. I want the maximum. So, negative X squared minus 500X. Window, how big do I need my window to be? From 0, do I need to go all the way to 1,000? No. 500 probably be enough. Really? 700? You should be able to go out to like 300 or 400 and be fine. I'm going to say 0 to 300. And I'm going to count by 30s. And then zoom 0. Wait, I didn't do something right. Oh, should be plus. And then zoom 0. Oh, it's not enough. So, okay. So let's go out to 600. Oh, I see what's going on. Okay. Well, sometimes I'm wrong. Oh, I counted by 6s. All right, we have an intersection there. I'm going to change my window so it's a little bit easier to see. I'm going to put 100 as my X value. So it looks like it hits at 500. Oh no, we want the maximum. Sorry. The x-intercept is 500, but we don't care about that. So maximum, I'm going to say 200 for a left bound, 300 for a right bound, and 250. And I get 249.999997, which means 250. Yeah, it all depends on your left bound, your right bound, and your guess. So what does that tell me? It tells me that X is 250. And then W is 500 minus 250, which is 250. So it tells me that this is a square. Now wait a minute. Did I need to do all that work? No, because... No. A square is the most efficient way to build a pen. Right? If we have 1,000 feet of fence and we want to make the area as big as possible, we want all 4 sides to be equal. Yeah. Is a square a rectangle? Yeah, it is. good question. So let's build a fence that's not square. Let's say this is 100. Okay? Then this would be 100. And how much do I have left? 800. So this one would be 400, and this one would be 400. So the area is 100 times 400. Okay? So 100 times 400. Oh, geez. 100 times 400. Okay? So that's the area. Well, if I do 250 squared, I get a much bigger number. So if you built your fence like this, how much area are you going to have in there? Very, very little. So the longer your rectangle, the lower the area. Okay? So the most efficient way, if you're just building a rectangular fence, is to use a square. Okay? Now, sometimes, if you start using fence in other ways, or let's say you had a building and you're building a fence there with a divider in it, then a square is not necessarily the most efficient. But if it's a rectangular fence, the square will yield a larger area than anything else. And on that graph, when we found the maximum, so 200, 300, and 250, the y value will actually be the area, if I could type it in right. So actually, let's just trace it. So as I go to the left, as my x gets smaller, then my area gets smaller. So this graph is all of the information about different fence lengths. So if your height is x, then your y value will be your area. And if you go to the left, right, you make the x smaller, the area gets smaller. Right, this is the area equation. Does that help? Okay, but a square is not the most efficient shape to build a pen. A circle is, well, why do we not build circle fences? They don't tessellate. Right? Is there you farmers, is there a problem with pivot sprinklers? You can't water a square field with a pivot unless you overwater. So you either underwater or you overwater. There's no way to water a square field with a pivot. That's one of the downsides of a pivot, is you lose your area. Does that make sense? Circles don't tessellate. So the area of a circle is pi r squared, and the circumference of a circle is 2 pi r. So we need to take 1,000 feet of fence, and we need to set that equal to 2 pi r to figure out the radius necessary to build a fence with 1,000-foot circumference. So we just divide by 2 pi, and we get r equals 500 over pi. Now what? Stick this in here. So pi times 500 over pi squared, and we get 2,500 over, or pi over pi squared, and this cancels that, and we get 2,500 over pi. So 2,500 divided by pi. Oh, I did it again. 2,500. Or wait, it's not 100. It's 25. It's 250,000, right? Yeah. 250,000 divided by pi, and I end up with 79577. Is that number bigger or smaller than the answer we got for the square? It's quite a bit bigger. So a circle is the most efficient way if you have the land to spare, right? If you have more land than you have water, then pivots are a great idea. If you have more water than you have land, and you want to squeeze every ounce of farmable land out of what you have, then pivots might not be the best idea. Okay. All right, last one, 99. So the speed of the river current is 1 over x plus 4 in quiet waters. The speed of the swimmer is 1 over x plus 11. When the swimmer swims down the river, her speed is 25 144th miles per hour. What is the value of x? No, I don't think you compose them. So this is our river. Okay, the current is going this way. How fast is the river running? So the speed of the river is 1 over x plus 1. Oh, 4. Thank you. Okay. Now, if we have a swimmer, when the swimmer, no, wait, that's not going to work. There we go. So the speed of the swimmer going this way, so the speed of the swimmer is 1 over x plus 11 when the swimmer swims with the current. Oh, sorry. Yeah, in quiet water. Okay. Thank you. So when the swimmer swims, then the swimmer goes 1 over x plus 1. Okay? When the swimmer swims down the river, her speed is 25 over 144. What is the value of x? So if I take the swimmer and put her in the water, then this speed and this speed add together. So 1 over x plus 4 plus 1 over x plus 11 is equal to 25 over 144. We'd want to solve for x. What do we do? Common denominators. Okay, we'll get this out of the way. So what is the common denominator going to be? It's going to be this and this, right? Well, we could probably get away with not doing that, but this one needs an x plus 11, and this one needs an x plus 4. So I end up with x plus 11 plus x plus 4 over x plus 4 times x plus 11. Does that make sense? All I did was find a common denominator, and this is equal to 25 over 144. Let me simplify. So 2x plus 15 over x plus 4 and x plus 11 equals 25 over 144. I have a couple options here. I could put a common denominator on the right side and then ditch the common denominator. Okay, but that's I would need to put a 144 on the left, and I'd need to put an x plus 4 and x plus 11 on the right. That will work. But what I'm going to do is turn this into x squared plus 15x plus 11, and then cross multiply and solve. So 144 times 2x plus 15 equals 25 times x squared plus 15x plus 11. And then multiply the 25 in, multiply the 144 in, move everything to the right side and factor, and I will probably get two numbers. One will be positive and one will be negative, and the negative one won't make any sense. Yes? Oh, thank you. Yeah, this will be 44. Okay, that's it.